Now I will introduce Charles Godfrey. He's a software engineer at BAE Systems. He has worked for BAE Systems for just over a year and a half. And in his spare time, you either find him tinkering with computers or out on his mountain bike. He also was trained through the National Security Academy. And without further ado, Charlie will be talking on how computers encode emojis and how those emojis support inclusion and diversity in the digital age. Welcome to DevLab. How are you, Charles?
I'm good, thanks. How are you?
Very well, thank you. Very excited to hear you speaking about emojis and diversity and inclusion.
Good, good. I won't get too excited.
A reminder, so for everyone who is watching, if you have any questions, don't forget that you can drop those on the comment section.
Right, amazing. So, yeah, like you said, I work at BAE Systems. I'm currently a software engineer, and I've been personally tinkering with computers since I was about 18 when I first built my own gaming PC. And I've been doing this professionally since I was about 23 years old. And if you don't know, BAE Systems is a defense company, and we basically build applications to help the government. And today I'm going to be talking to you about emojis and how they work and how they help support diversity in this new digital age. Computers are bad at a lot of things. Computers are bad at emotions. My computer doesn't care if I'm happy, sad, or if my code isn't working and I'm on the brink of smashing it. They are also bad at uncertainty. So computers always deal in truth or false. They don't like having a situation where they don't really know what's going on. Social interaction, I don't know about you, but I can't really talk to my computer and it doesn't really give me a thrilling conversation back. And human language. And this is a combination of all of the above, just because computers can't do it very well. But computers are good at numbers. So computers deal amazingly with numbers, as you all probably know, that they like dealing in numbers and they break everything down into numbers. But yeah, so you can see here is the alphabet, and you can see that we've broken it down into the numbers. So it's from 1 to 26. And this is basically a character encoding. So you can see underneath that I've encoded my name, Charlie. I know it's Charles, but I like to be called Charlie, really. And you can see that we've broken it down into the numbers 4, 8, 1, 18, 12, 9, and 5. And then this was the part where I was going to say, can anybody decode the numbers that I've got there? But as you can see, it spells empowered. But so when you are character encoding, that is a very simple in character encoding, but there are things missing. So computers need numbers for basically every single thing: uppercase, lowercase, punctuation, even a space. So I just get the next slide up. Basically, there was a time in the 1950s where people were all creating their own character encoding, and basically because everybody was having their own little different spin on it, computers just were finding it really difficult to talk to each other. So that's when a group of people basically came in and they decided they'd make a thing called ASCII, was the American Standard Code for Information Interchange. This, as you can see, is a lot more than just 27 numbers. It's 127 for 128 characters. This includes punctuations, lowercase, uppercase, and then even little things like control keys. So this was like delete, and they also had a ding one, what was very, very useful back in the day because they needed computers to ding. But you can see that if anybody's noticed, it goes from 0 to 127 for 128 characters. Now, I know this might seem a bit weird, but basically it's a power of 2. Computers like storing things in boxes of a certain size, and 128 is just a nice size box to keep things in. But then you can see here, they also created hexadecimal. So hexadecimal is broken down into 6 digits and then 10 digits, what creates 16. That's why it's called hex for 6 and dec for 10. And then this gives you a 16-bit. And then, as you can see underneath, this basically breaks it down even further so that when you write hexadecimal, you can see that's a 0x to A. And these numbers associate to numbers on a computer. That's the main thing I'm trying to get through to everyone. And that's as much as hexadecimal as you're going to need to know. So if we go back to ASCII, you can see here that the ASCII is also using hexadecimal now. So you can decode stuff, as you can see here, to letters and numbers. So here we've got hello, but I did do a bit of a sneaky thing there where the O in hello is actually a 0 and not an O. So if anybody noticed that, well spotted. But ASCII and hexadecimal can only take us so far, just because there is so many different languages within the world that if we only had people trying to speak English, then this obviously wouldn't be very inclusive and diversity. I'm pretty sure the statistics on people who actually speak English are only 5% in the world, and that's only reading and writing. If we broke it down into people who could only speak English, that's only about 20%. So we've still got all these different characters from all around the world what need to be basically created so that computers can read them. And this is basically where Unicode comes in. So Unicode, their vision for their company is basically everyone in the world should be able to use their own language on phones and computers. And now I'm going to talk to you a bit more about how Unicode basically breaks everything down and makes it so that computers can see them. So it abandons the attempts of previous encodings to squeeze all of the characters into 1 byte or 256 slots. And the popular way to store Unicode strings is to use between 1 and 4 bytes per character and can encode over 1 million different characters, but we'll come back to that later. So you can see this is a list of scripts that Unicode supports. So it's European scripts, African scripts, but then you can see there just at the end, it also does emojis and pictographs. And this is exactly what we want to be talking about and what we're going to be learning about. And emojis. So I know it's been about 17 minutes into this presentation, but we're finally going to talk about emojis and how these things actually work and how they can improve our diversity. So computers should all be about people. It doesn't matter how you look or what kind of job you are or what sex or gender. Computers should basically be inclusive to everyone. So in the late 2000s, when mobile phones really took off, basically people needed a way to communicate how they felt and looked and everything like that. So Unicode got on board and started to make unique codes for all emojis. But we'll talk about emojis a little more in a minute. So I've said every character in Unicode gets a unique code. This is called a code point. So here you can see the range of code points, and you can always tell that it's Unicode because it always starts with a U+. We can see that a lot of these have different ranges, but normally for the emojis, you can see at the start that it's U+1F. This is basically the section in Unicode that is dedicated to emojis. So you can see here, there's lots of tools and different tools to create emojis and Unicode them. But here's the official Unicode site. So these are the codes for these particular emojis. You've got the Latin eye, a heart-shaped emoji, and my personal favorite, pizza, because I love pizza to death. So this part may not work that well just because you're supposed to like go off and do these, but I do recommend going to the unicodetable.com and just having a little poke around and just having a bit of fun with it. But a thing that you will find very difficult and run into straight away is that there is many different emojis meaning very similar things. So if you go onto the Unicode site, you'd see there's 2 snowman emoji. There's about several different kinds of sun emojis, and the water one is very hard to find. So this is the one problem with having so many symbols. It can be hard to find them, and you need to make sure that they look similar on different platforms. So encoding and decoding. You can see in Unicode that basically there's a lot of different emojis, especially for different people. So you can see here on the left-hand side, we have a man waving, and then we also have a policewoman. But if you put these codes, if you try and search for this in the Unicode table, you'll most likely come across a woman waving or a male policeman. And this is definitely not what we're going to do in a inclusive and diverse world, because say a female wanted to show that they are a police officer, they're going to want to have the police officer, but as a woman emoji. Same with if someone had a different skin tone, they'd want to make that and promote that. So in this vein, we don't want to reinforce old stereotypes of that men should be police officers, or that the different skin tones aren't the majority and everything like that. So this is where Unicode really wants to push this and make this technology more inclusive and diverse, because we found that a lot of people, when they send emojis, want to represent their skin tone or their gender. And a lot of studies have shown this. And because you are the next generation in computers and learning and dealing with computers, we want to make sure that you can use this and express yourself in what you see fit. But let's get back to actually Unicode and how it actually works. So I mentioned before that we have specific codes for specific things and emojis. But if we had a unique Unicode for every single different skin tone and gender, then we would significantly use all of those different specific codes within years. So Unicode has created a thing what basically joins different types together. So as you can see here, we have a white woman emoji, and then we have a darker skin tone. And then this is basically pushed together to create a new code, what is the that dark skin toned woman. So say I wanted a man with a light skin tone. You can see here that it actually creates the man with a light skin tone here, because it basically joins those 2 skin tones together. But then say I wanted a superhero and I want them with a dark skin tone, you can see here, and it pulls those together, and that it basically brings those 2 codes together to create that unique emoji. I do recommend going on here and having a little play, just because it is quite fun, especially when you can see how the codes actually interact. So I will link these after the presentation. So you have the joining emojis. And basically, there are some emojis where it's easy, where you can just link the person with their skin tone. But then you also have different emojis, such as this police officer. So the default police officer is that. And then you have a thing called a zero width joiner code, what basically means that you can join a gender to a specific emoji, just like we've done there to create a female police officer. I do want to know, Unicode does say that all these should be gender neutral when they possibly can be, so not to reinforce any different stereotypes. So you can see here, these are different, just some more examples of joining emojis together. So you've got a man with a zero width joiner of just a wheat emoji, and you can see that that creates farmer. You have 2 women and a child. What? Oh, sorry. You have 2 women and a child, what creates a a gay family, and then you've also got a woman, her darker skin tone, and a astronaut rocket, which creates a black astronaut. And this also is used with different companies who like to push different types of agendas. And you can see here that they actually made a period emoji to basically help promote menstruation and just chop down those taboos in terms of women's menstruation and that kind of things. And this basically really helps to push their agenda and help get the message out there. And yeah, basically my final talking point is that's all you really need to know about emojis. I do recommend going to those Unicode websites and just having a little play around, because it's really fun just to have a bit of a thing. But what we should really be focusing on is just supporting diversity and social change around the world using technology. Everybody wants to be able to express themselves and how they feel is right. And this is where emojis can really help just push that agenda. And I know talking about emojis seems like a bit of a silly thing. You know, they're just like funny things that I send to my friends all the time. But if we can make a small chunk in just helping the world with little things like that, then I think that's brilliant and we should really promote it. Is there any questions?
Amazing. Thank you so much. I honestly, I use emojis all the time. I don't know if everyone who is watching can relate or not, but I'm a big fan of emojis. Anyway, I wanted to know, in your career, how important has the tech community been for you?
The tech community, yeah, it's been really important in my career. Just I do recommend, if you do want to get into technology, a lot of things that I did was just attend career meetings, tech talks and stuff. There's a good app that I used to use called Meetup, where you can basically go and talk to a lot of technical people and learn about different technical skills. I know when I first started, a lot of people did. There was a lot of talks about different technologies that I was like, oh my God, this is so overwhelming. I've never heard anything about this. Thinking, oh, I can't do this. But everybody's so helpful. And it's one of those communities where they'll never leave you to the wayside. They'll always pull you up and say, yeah, no, let's teach you a bit more. And there's so much resource online that you can use.
Amazing, thank you. Thomas said on the comment section, I often use I don't know if I know how to say this, shortcut in Windows 10, 11 to insert emojis everywhere. It's interesting that it even works in Notepad for the most common emojis. You're right that platforms render the emojis differently, and you can't guarantee how it renders for the recipient when sending cross-platform.
Yeah, that's a great thing to notice and see, just because obviously different technologies, different companies like to build things. So I know like Google and Apple, they have their own different user systems. And I don't know if you've ever had it where if you're texting a friend who's on a Apple device, or you're on an Android, and you'll just get given like an alien emoji. That's basically the device saying, oh, I don't know this code, what you're coming in, but I know it is an emoji. So I'm just going to stick this weird alien face saying, oh, we don't support it. Which when you're younger, when I was doing it with my friends, we used to laugh loads because we had no idea what was going on. So we'd be like, oh, your phone's broken, oh, ha, 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 like that. And yeah, tech superiority.
And changing a bit the subjects, just because I know that a lot of people who are watching now are looking for entry level roles. So I just wanted to know, what requirements do you need to have to do a degree apprenticeship at BAE Systems?
That's a brilliant question. So I've never been to uni. I've always just been in a job. I've only just done apprenticeships. My past is in actually digital marketing. That was my first apprenticeship, and I did that, and then found that I more liked actually playing with computers and doing code than actually like selling digital marketing things. So all I'd say is, as long as you've got the passion and the drive, just make sure that you just do your own little projects at home. That's what I did. Built my own computer, built small applications, and for the NSAC apprenticeship, yeah, it's built to help people get into the industry who haven't had such a technical background, because BAE Systems, they don't just need technical people. They need the right qualities in a person who can work in a team, who can talk to people, can explain technologies, and you can always learn code. And that is one thing I would always hammer through. Code, you should never be scared of code. When you're doing it, you'll pull out your hair a bit sometimes, just because you will get a bit frustrated. But you can always learn code, and you can always learn about new technologies. So that's what I'd say.
Thank you, thank you. And then now that we're talking about BAE Systems and coding, what was the most exciting project that you were involved with BAE Systems?
I can't really talk about my projects and everything, just because
Oh,
they are a bit enclosed. But I will say, when I was doing the National Security Academy, the final project that we did was to make basically an application where it would use different locating things, like location devices such as like speed cameras and stuff. And we basically made something that could find specific users. So I made it so you could enter a registration plate, and it would basically map where that person has been on a nice interactive map where they've actually been around the country. And that was just a small taster into what we can actually do and what we do at BAE Systems. But I love that project. I sit at home and I play with it still. Like, it's brilliant.
thank you for sharing. And I don't know if you can tell us or not, but what are the progression opportunities at BAE Systems?
Now I can talk to you about that. BAE is really good at promoting and building up their engineers and people who work for them. So for me, I'm on a 2-year payment plan at the moment. So I'll get a raise and stuff like that for the first 2 years that I'm in here, because I'm still basically a NSAC graduate. But they'll always build you up. I have a career manager that I meet with every single week, and we always talk about things that I want to do. So a great thing as well about BAE is, say I was like, no, I hate software. Software engineering is boring. I don't want to do that anymore. I want to do something more DevOps engineering, for just to say. The company and my career manager would go, right, yeah, that's perfect. And they would help build me into a DevOps engineer and move me onto a DevOps project, instead of just leaving you in the corner saying, no, that's your job, here 9 to 5, don't care if you don't like it. They really help to build people up.
That's amazing. Andrew asked, if you have done a coding bootcamp, would BAE Systems still take on someone as an apprenticeship? Sorry.
Yeah. No, yeah, definitely. So the NSAC apprenticeship is open for basically a wide range of people with different backgrounds. So like I said, I never went to uni. I never studied computer science. It was only a little personal passion that I found that I really wanted to get into. But I know a lot of people on my academy and my course, they did go to uni. They went to they did computer science degrees and everything like that. So if you can do a coding bootcamp and you can show off that your coding capabilities, they'll be really impressed with that, and I'm sure they'll take you on.
Perfect. And Andrew also added, do they have remote roles?
So yeah, COVID definitely changed the landscape of how BAE works, and yeah, my whole training course was online, so it was 14 weeks remote working, and then we've only literally started to go into the office about a month ago. So for the first like year and 5 months, I was just in this bedroom coding on calls. So it doesn't really matter about the location anymore, I'd say, because you can do all of it online and remote. there's only certain things you'd have to go in for, but they come few and far between.
Absolutely. Thank you so much. Thank you so much for the session and for answering all the questions. I really enjoyed it.